All right, so what we're going to look at is just some more implicit, just some little bit of application with them. So I have on here a function. This function is actually called an asteroid. There's some famous curves in math. This one is called an asteroid, like your parabola, your circle, your ellipse. This one is kind of like a convex ellipse. Its function is the function x to the 2/3 plus y to the 2/3 equals 5. So again, it's kind of like a circle or an ellipse, but instead of being concaved out, it's concaved in. And so what we're going to do is we are going to look at this, and you see how I have a point here at 8, 1. We're going to actually try to find the equation of the tangent line. So we're going to look for the equation of the tangent line at 8, 1 of this asteroid. So we're going to use implicit differentiation because this is not an equation that I can easily solve for y. So my first step is to take the derivative. So the derivative of x to the 2/3 is 2/3 x to the negative 1/3 plus I'm going to have 2/3 y to the negative 1/3 times dy dx, because y is not in terms of x, equals the derivative of 5 is 0. So then I would have 2/3 y to the negative 1/3 dy dx equals negative 2/3 x to the negative 1/3. This is kind of similar to a problem you did on the Canvas assignment. So when I solve for dy dx, 2/3 and 2/3 are going to cancel. So I'm left with negative x to the 1/3, negative 1/3, sorry, over y to the negative 1/3. And remember, when you have negative powers, you want to make them positive. So making these positive would literally just flip these around. So I'm going to have negative y to the 1/3 over x to the 1/3. That's my derivative, that's dy dx. But what I really asked for was the equation of the tangent line. So in order to do that, I need a slope. In order to find the slope, I need to plug 8 in for x and 1 in for y. So when I do that, my slope, or m, is going to be 1/2. Because 1 to the 1/3 is 1, 8 to the 1/3 is, 8 to the 1/3 is 2. So all I did was plug in 1 for the y and 8 for the x, and I get 1/2. So then I could write y equals 1/2 x plus b. And then now you're going to do what my kids are doing in algebra right now. You're going to put in your point. So 1 equals 1/2 of 8 plus b. So that's 4. So b is negative 3. So y equals 1/2 x minus 3. And I think I still have this up on Desmos, so we can look at it. I do. Y equals 1/2 x minus 3. That's 4. Minus 3. Oh, shoot, it should be negative 1/2. I forgot a negative. Let's go back. Sorry. Of course I forgot a negative. So this is negative. Let's erase this for a minute. So this is negative. So then I would have, I would still have 1 equals negative 1/2 x. Well, x is going to be 8 plus b. So that's going to give me negative 4 equals 1. So that's going to give me b is 5. So y equals negative 1/2 x plus 5. Sorry about that. I think I've told you guys before that I'm really good about making positive and negative errors. There was one of them. And this is negative. And if you look, that looks much better. There's the slope of that tangent line. So that's one application, is finding the equation of the tangent line. On your doodle notes, we did a slope at a point, the one that had a lot of algebra. And you might have one of those today with a lot of algebra, but you can use that as your example. All right, the other thing that we want to look at with these is finding horizontal and vertical asymptotes. So when we did a regular derivative, explicitly, we only could find the horizontal asymptotes. But because we're taking a derivative in terms of x and y, now we can find what we call vertical and horizontal tangents. So I say asymptotes. They're not technically asymptotes, they're the tangent lines. So to find a horizontal tangent, this is what we've done before. You set it equal to 0. A vertical tangent would be where your slope is undefined or does not exist. So let's try a problem. Hopefully I don't make any errors with my positive and negative numbers here. So I have 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. So if you look at this, going back to pre-calc and algebra 2, this is actually an ellipse again. Because x and y are both squared, but they're different coefficients. So it's not technically a circle. It's nice to know what it looks like, but it doesn't really matter what it is for us to find the derivative. So first thing I want to do to find the horizontal and vertical tangents is take the derivative with respect to x. So this would give me 8x plus 2y dy dx minus 8 plus 4 dy dx. That's 0, that's 0, so equals 0. So I'm going to move 8 and negative 8x over here, so I move those. And then when I have this, I can factor out the dy dx. I would have 2y plus 4. I kind of skipped a step from what we did the other day just to save time. To solve for dy dx, you're going to have 8 minus 8x all over 2y plus 4. So that's the derivative implicitly. So first, to find the horizontal tangents, this is the ones we've been doing, you set the function equal to 0, or your equation equal to 0. So if you set this equal to 0, 2y plus 4 times 0 is just 0. So really what you have is 8 minus 8x equals 0. So if I do that, x equals 1. So my horizontal tangent happens at x equals 1. So x is 1. We have to find the y value. And here's the thing. This is probably going to have more than one y value because it's an ellipse. So let's try to find that y value. To get the y value, you have to go back up to this equation right here, and you have to plug in 1 for x. So to get my y value, I'm going to plug 1 in for x. So I'm going to have, if I put 1 in there, that's going to be 4 plus y squared minus 8 plus 4y plus 4 equals 0. That's supposed to say equals 0. So when I do that, 4 negative 8, that'd give me negative 4 plus 4 that's just 0. So I'm left with y squared plus 4y equals 0. I'm going to have two answers because it's y squared, so I can factor. So I get y times y plus 4. So my answers would be 0 and negative 4. So my horizontal tangent lines are at 1, 0 and 1, negative 4. So I'm going to go to Desmos real quick and show you what that looks like because I think I have it graphed still. Let me get these off of there. So here's that equation. So my horizontal tangents are when x is 1, 0, and the other one would be here, 1, negative 4. You can tell these would be horizontal tangents. Now we're going to find our vertical tangents. By looking at this, I should have 2. There would be 1 here and 1 here. We should have 2. So we have 2 horizontal, we should have 2 vertical because it's an ellipse. So let's go back and show you how to find the vertical. So what you do is you still have your derivative, which was 8 minus 8x over 2y plus 4. So what we want for the vertical tangents, so this is for vertical, this is new, For vertical tangent, you want it to be undefined, does not exist. What you have to remember is this function right here would not exist if the denominator was 0. So in order to find the vertical tangents, I'm going to find where the denominator is 0. So 2y plus 4 equals 0. So if I solve for that, I get y equals negative 2. That's the y value. Again, I know I'm going to have 2 because I already looked at that. So I'm going to put negative 2 in for y, and I'm going to find x. Which equation am I going to use? I have to use that original equation. So my original equation was 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. So now I'm going to put negative 2 in to find my x. So I'm going to have 4x squared, negative 2 squared is plus 4, minus 8x, minus 8 if I put negative 2 in there, plus 4 equals 0. Now if you notice, something happened, same thing that happened before. These three numbers cancel to 0. So I'm left with 4x squared minus 8x equals 0. I can factor out a 4x. And so my answer would be 0 for one of my x values, and my other x value would be 2. So let me go to Desmos so you can see what that looks like. The vertical tangents would be at 0, negative 2, and 2, negative 2. So that's where my horizontal or my vertical tangents are. So I have 2 vertical and 2 horizontal. So if you're doing one today that has for vertical and horizontal tangents, go ahead, you can graph it, but I would want you to try the work to make sure that you understand how to do those derivatives. Okay, so that's it. Go back to Canvas and see what you need to do. Sorry for the long video and the mistake.